Okay, then we'll move on to our featured speaker. This is our speaker today is Andrew Panelli. Andy is both undergraduate and graduate degrees from the University of Notre Dame. He leads a chapter for the nonprofit and nonpartisan group Citizens Climate Education, making presentations and educating the public on effective solutions to the climate change issues. Today's presentation is an interactive program. That means you have to participate, where your participation is encouraged and which focuses on not only the scientific-based arguments for taking action, but also refocuses on a compelling case for solutions that are both in line with conservation principles and delivers desired outcomes that include freedom of choice, quality of life, enhanced national security. We want to hear about that one, and economic well-being. So please engage in this interactive discussion to provide feedback on approaches and whether the proposed solution meets a conservation litmus test. So please welcome Andrew Panelli.
Thanks, everybody, and it's my great pleasure to be here. Today, we'll be talking about solutions to climate change, and we'll talk a little bit about some of the causes. We'll brainstorm solutions together, and then we'll test the solutions that you recommend on a state-of-the-art climate simulator from MIT Sloan that is calibrated to some of the world's most respected supercomputer models. At the same time, we will look at some climate legislation that is kicking around Congress, and then we can see whether we think that legislation might be helpful for what we want to do too. I'm going to set a timer here because I know we're tight on time, and we're kind of compressing this. We're compressing our presentation a little bit, but we'll have time for questions and answers. So, and then we'll wrap up with things that we can do as individuals. So, with that said, we know that from the turn of the last century in 1900, we can see that from NASA and NOAA, there's been a steady increase in our temperature over the last, since the turn of the last century. Basically, we have the temperature rising. 2023 was the hottest year on record. We increased a whole quarter of a degree Fahrenheit just in 2023. So you see where the trend is going there. And the next slide, why is this happening? Well, if you look at in the upper left-hand corner, where we see these half a dozen premier scientific organizations that you've heard of, there's another dozen that you probably haven't heard of. All say that it's because of additional CO2 emissions in the upper atmosphere, and primarily from human activity, primarily from burning fossil fuels. Now, this is the consensus science. It doesn't mean every scientist believes that. And but it does mean that the vast majority of peer-reviewed climate scientists believe it. So you may not believe it, you're not alone, but you might want to participate with us because you may want to do it for some other reason than climate. You may want to do it because of cleaner air or cleaner water. But so where did all these carbon emissions come from? Well, as we again see from the turn of the last century, we are probably putting out a modest 7 or 8 gigatons of carbon emissions per year. But around World War II, we start to see it spike, and then it continues to spike all the way to today, where now we're doing 60 billion tons, 60 gigatons of carbon emissions into the atmosphere every year. It compounds, it doesn't go away. Methane lasts for 80 years, CO2 emissions last 1,000 years. What we put up there every day stays up there for a long, long time. Where did it all come from? Well, in the gray area, this is from burning fossil fuels. And when they're talking about greenhouse gas emissions, the green area is from forestry changes. Forest that used to absorb carbon dioxide, but it's been leveled for agriculture or maybe deforested and for some other reason. In blue is methane. Methane is nearly 20%. Direct methane release into the atmosphere from mining, from industrial processes, but also agriculture, our animal husbandry, but also our landfills releasing methane directly up to the atmosphere. Sometimes you might see flaring where they're trying to burn it off, but the flares aren't working properly. So a lot of leakage with methane and the way we pipe it around. Nitrous oxide, N2O, is from fertilizer interaction with the soil, and that gray slip is F gases from refrigerants. Now, all these bad things happen because as the world gets warmer, we have more intense storms with hurricanes. We have more and longer lasting droughts. We have more and more intense wildfires. We have flooding. You mentioned the defense. The defense keeps an eye on this stuff because national defense becomes an issue, because when governments become destabilized due to climate change, and there's a lot of climate refugees, this can create political chaos, which can invite a breakdown that can result in drawing us into a conflict that we might have otherwise not been drawn into. But all of these bad things that happen because of it, if some people say, well, really, we can't afford to address climate change, but this Deloitte, one of our premier accounting firms, tried to put a number on business as usual. If we don't do anything, they came up with the number of $178 trillion in destroyed property, climate-related costs if we don't do something about it. So others might think, hey, we really can't afford not to do anything about it. Now, what we're going to try to do today is our climate simulator would project an end-of-century temperature. If we're already at 1 degree centigrade from the turn of the last century, the simulator would project a middle-of-the-road scenario that would be about 3.3 degrees centigrade. Most climate supercomputers would put it between 3 and 4, somewhere between 3 and 4 degrees C. What we're going to try to do is bend this curve and keep it between the 2 red dotted lines, which is the Paris Accord. Now, 3.3 degrees C, or about 6 degrees Fahrenheit, may not seem like a lot, but let's remember that it's going to be cooler over water and hotter over land. Let's remember that it's an average temperature, so it might be 3 degrees Fahrenheit some places, but 10 degrees others. And let's keep in mind that the temperature hasn't been this consistently warm for several million years. So it's very important that we work together to bend that trajectory. We're going to be using the En-ROADS climate simulator. It's loaded with the most recent information, along with historical information from credible organizations like the IPCC, the International Energy Agency, our own U.S. Energy Information Agency, and also the World Bank and the United Nations on population projections. And it is calibrated to some of the world's top simulators. So what we're going to do is we're going to start brainstorming real quick. I want you to start throwing out ideas that you might have heard somebody talking about, that you thought, well, if everybody did that in the world, this could make a meaningful difference. You might have seen a state do something. You might have seen another country do something. You might have been involved with a company that was doing some things. But we need some ideas. Dr. Pat back there is going to be writing them down, and we're going to test them. We're going to test them on the simulator. And and we're going to test the results of them and on the simulator to see whether some are more meaningful than others. So I'm going to pull that simulator up, but we're going to actually pretend here that your voice is so respected in the United Nations that if you make a suggestion, everybody's going to want to do what you say. So let me stop sharing screen and pull up the simulator and tell you how that works. So in the upper left-hand corner, this is the projected energy usage over the rest of the century. That in brown is the coal usage, red is oil, blue is natural gas, green, which you can see is just a little bit here in 2024, is the projected growth of solar, wind, also hydro and geothermal. This is the renewable energy. In pink is biofuels like ethanol. And then that little tiny blue sliver at the top is nuclear. So if we burn all of this, plus with the projected land use changes that are anticipated, we get this amount of net greenhouse gas emissions here. So we can see in 2024, there's our 60 billion gigatons, or 60 billion tons, 60 gigatons of carbon emissions. And that is driving this 3.3 degree temperature as it continues to grow throughout the year 2100. So what we're going to try to do, and watch that blue line as we just randomly move some of the levers here, it changes the mix. See, and when the energy mix changes or land use patterns change, it starts to pull those greenhouse gas emissions down, and that lowers the temperature. So that's what we're going to be, that's the principle we're going to be working on. And we have a couple of tools in our toolbox. If there's something we don't like, we can put a fee or a tax on it. If there's something that we like, we can put an incentive or a subsidy on it. Those are the two things that we're going to be working with here. So if we don't like coal or oil or natural gas because they provide carbon emissions, we may want to retard that growth with a fee. Bioenergy, we have to decide whether we like that or not. Renewable energy, we might like because it's carbon free. Nuclear, we know there's a nuclear waste problem, but it's also carbon free. Or we might try to experiment with some new zero carbon technology like nuclear fusion or thorium fission, cheaper than coal, but emission free. Or we can talk about a carbon price. A carbon price is not like taxing the product, coal or oil. It puts a tax or a fee on the emissions of those products when they're burned. So transportation is a big sector. Well, what about more efficient transportation, like President Obama's CAFE standards, 50 mile per gallon vehicles? Or we can electrify vehicles. We can also look at building an industry, which burns a lot of fossil fuel to heat the buildings, and it takes a lot of energy to run all the appliances in the building. We can tinker with population growth. We can play around with economic growth. We can look at deforestation. We can look at methane or other gas emissions. President Trump's trillion tree program may be a possibility, or we can look at technological fixes like equipment that can actually pull carbon emissions out of the air, and then you can heat it up and pump it underground. But there's lower tech solutions also, which is our lower tech solution might be regenerative agriculture, no-till farming, which locks carbon into the soil. So now it's time to brainstorm. Need everybody all in on this. We got to start throwing out ideas. We got 10 minutes to save the world here and get that end of century temperature down. So Dr. Pat will write let's start throwing out ideas. What do we think we could do? Go ahead.
If I recall how we got adults to recycle, we educated the junior and senior high school kids, so they would go home and say, hey, mom and dad, why aren't you doing this? So it's like even the woman with the vegetables, they educate the junior and senior kids, and then they go home and pressure mom and
So
dad.
if you were gonna educate them, what would you educate them on? What lever do you think we ought to pull here?
That one
Go ahead.
Tax carbon.
Tax carbon. Okay, you want to put a carbon price on it?
Yes.
Okay, write that one down too, Dr. Pat, along with education. What other ideas do we have? Yes,
We could improve, there's a lot of leakage in all the mines and
yes.
like, I think it's either
Methane.
methane, and it escapes into the air. We should do something to make that.
Methane. Okay, other ideas? Yes,
Heavily tax the fossil fuels so that your goal is to eliminate it eventually.
okay. Tax on the fossil fuels. Have you noticed anything about vehicles that are being produced today? Any changes there that you think might be part of the solution?
Well, I often wonder about the electric vehicles
Electric
because
vehicles.
the way that they get the electric power to power them, even though they're not emitting, to make the fuel that powers them makes emissions.
Okay, yeah. Yes,
How about farming?
Farming.
Regenerative
farming,
farming.
very good. Regenerative farming, any other ideas? Yes,
I grew up in Wisconsin and the farmers always had windmills to
windmill,
gather the energy from the wind. We can do that in the city.
yes, renewable energy, very good, very good, yes.
What if we relocate all the renewable development of those type of like windmills and such in places like West Virginia where they make coal?
That's right, yeah, yeah.
So.
Yes, there's actually some legislation that we'll talk about that's doing exactly that. Yeah, very good. Well,
Dan
we've got some,
Chakowski suggested that we have windmills in Lake Michigan on the curve between Evanston and Chicago. And some people in Evanston thought that was unsightly, even though it would have been a way to generate energy.
yeah, very good. Well, we've got some great ideas. Let's start. So with electric vehicles, you raised a good point. So if we try to electrify not only cars, but trucks, trains, maybe eventually ships and planes, what do you think that would do to our end of century temperature? Or would it bring it down a little, which might be 0.1 C, or would it bring it down a lot, which might be 0.4 or so C, 4.5 C? What would you think
I
that would
would
do?
think it would be a wash.
You would think it would be a wash. Let's test it. They didn't do much, did it?
The wash.
It's a wash. And for exactly the reason that you said, is that if that car is being plugged in by a coal-fired power plant, it's not doing us that much.
That's
It might eliminate some smog. But but if at the same time, and someone suggested taxing fossil fuels, we put a tax on that coal, a significant tax on there. Let's see what that does. We're going back now, and you see where coal was in brown, and it's shrinking a lot. And now that we've electrified vehicles and we've taxed coal, that's brought that right down. If we could get an agreement from the countries of the world to stop building new coal, leave the old ones up, but stop building new coal plants, we could see that we would get even an additional boost. Accelerating coal plant retirement would give us another 1/10 of a point. Great, we're well on our way. Let me share screen again there. and pull that back up. So, we have now, someone mentioned, regenerative farming. So, what, you think that'll do for us from an end of century temperature? Lot, a little? What do you think?
Lot.
You think it'll be a lot? Okay, let's go in and, we're gonna test regenerative farming. Carbon soil sequestration. Let's see what that did for us. A tenth of a degree Fahrenheit, but it's still worth doing, even though it didn't give us a huge boost.
What about methane, leaking methane that was mentioned?
Leaking methane, yes. Methane, who had that suggestion? Oh, yes. Do you think that's a big movement or a small movement?
Oh, probably small.
Well, I want to tell you something. That's a very big one. And
Oh,
if we were, so if we reduce it in our, if we reduce it in industry and we can get it down 75% of all it leaks out, that was a big hit. That hasn't changed our energy mix here, so there's still lots of opportunity there. But look what it's done. It's knocked it down 0.2 of a point. Yeah.
If you were to recapture the methane from the landfills and use that as energy,
Yeah, you would get an
Is that the
even,
same?
you would get an even bigger boost there. That would, that would kick that up, and you might get another point out of it if you could be more aggressive on stopping the leakage of methane everywhere in industry. Yeah,
Now,
good suggestion.
what about incentivizing, renewables like windmills and stuff?
Oh, yes, thank you. Renewable energy. I'd ask whether you thought that was big or not. You might be disappointed a little bit, just because if we incentivize, put a nice rich incentive on there of maybe a nickel per kilowatt hour, it didn't do too much for us. And part of the problem is, and we absolutely should do it, but you see how fast renewable energy is already growing because it's cheaper than coal. So it's taking it down probably 1 degree Fahrenheit, or 1/10 of a degree Fahrenheit.
I
Yeah.
don't know if you can demonstrate, what if we went to local farming rather than bringing all the, food from Brazil and?
Yes, okay, well, that speaks to energy efficiency and transport in particular, and that you just got us another 1/10 of a degree. So we also had somebody say carbon pricing,
Carbon tax.
carbon tax. Watch what happens with a healthy carbon tax. And then all you've got to do is maybe plant a few more trees or stop cutting so many down. And congratulations, you got us.
I know you do it.
You got us into the Paris Climate Accord range. Now, let's go back to our presentation for a minute.
Oh, I like this better.
Okay, hang on.
can you tell us about the Paris Climate Accord? Is that,
So the Paris climate targets were had a stretch target of 1.5 degrees centigrade to 2 degrees centigrade, and the countries of the world agreed to that.
Did you do
Why did they-
electrification of buildings and stuff like that? Can you push that button?
Yes, let's try that.
why didn't they agree to zero?
You see how hard it is to,
Enforce.
yeah,
Well,
they're trying to agree to get to limits. Let's see, did I stop share here?
Is China part of the Paris Accord? They have the largest population in the world.
Yeah. They are part of the accord, although they have not agreed to net zero by 2050. They agreed to net zero by 2060. So they're using still a lot of coal, and they're kind of dragging their feet a little bit on that. So the Inflation Reduction Act would have gotten this done. Let's wrap up. I'm running a little over time. Sorry about that, but what can I do? You know, there's stuff we can all do, whether it's composting that was brought up before, whether it's, you know, eating lower on the food chain, whether it's turning the thermostat down or up, depending on the season, driving less, flying less. But where the rubber really meets the road is when you can change the system. And the Inflation Reduction Act, this legislation, carbon pricing, which hasn't been passed yet, but we're still working on that. And we need everybody writing their congressman. You saw what the impact of that was, and telling them that we need carbon pricing. When, you know, we've got so much carbon baked into our building permitting process, agriculture, and until we change the system, that's where we can make real change. And that's what Citizens Climate Lobby is here all about. We've got thousands of people that are knocking on the doors at the halls of Congress, trying to get things done. We need everybody all in on this, because if their constituents are calling and writing them, at least once a month, they're not hearing it often enough, so that when we knock on their doors, it's meaningful. So let's keep talking about it. Let's keep, advocating for methane control, and carbon pricing, building electrification, and building efficiency. And then if you know anybody else that could use to see a presentation like this, you know, we do these for free to try to educate people.